Back, download is done. See what we got here. One of the most important things you're going to be spending a lot of time looking at is the Pandaboard specific files. In particular, the README has some really indispensable information. The only thing that I would recommend is that they suggest that you first build enough of the operating system to be able to get the device into fast boot, and then once you've done that, you go and build the rest of it. I don't think there's any reason for that. Just build everything top to bottom, and then when it's all done, we'll go back and flash up the device all at once. But the important thing that they do talk about here is we need to download the proprietary binaries. So if we take that address, here's a whole bunch of old archived Pandaboard binary files. You want to get the latest one. So here's the one dated from June of 2013. That's the latest one. So let's just click on the link here. It downloads real quick. Okay, so we've downloaded the proprietary binary. Let's go back to the top of the source tree, copy in the tar file that we downloaded, and extract it. And when we did that, we got this shell script that came out, so let's run that. And it wants us to read the license. Okay, so now those are extracted. That just created this vendor directory, which has the proprietary stuff in it. Okay, now there's only one patch that we're going to need to make before we start building. So we need to go back in the Pandaboard specific stuff. And there's an init file that has one flaw in it. Okay, so we're looking for this line here that starts the SD card service. That has a bug that should be emulated, not SD0. This is the service that will start the SD service that simulates the external storage on the Pandaboard. And if we don't have that, you don't have any external storage, and that causes all kinds of problems. So we made our one patch. Go back to the top of the source tree. And first we have to set up our environment. So we pull in this setup env script that does all that stuff. We type in lunch and we look for the version that says Panda. So we choose that, and that sets up our environment. All this stuff is in that README file that we looked at before. So if you want written instructions on what I just did, you can look at that. But at this point, everything is set up. All we have to do is type in make. And this is another really long operation. Definitely not a get a cup of coffee. This is, again, a 2 or 3 hour thing. So let's just let that go at it, and we'll come back later. Hi, we're back. Hopefully the build succeeded, and we're now ready to move on to the next step, which is flashing the device. But before I do that, I just wanted to point out that if your work gets interrupted for any reason, you can always reinitialize your environment by simply going to the root and rerunning the env setup script, and then lunch. Something which I did not mention before is that when you set up the environment, it's putting functions into your shell. Let's look at the setup script real quick. There's actually a bunch of helpful functions that get installed into your shell when you run the setup script. So that's why you won't, if you look, you won't find an executable for lunch. There's a variety of interesting functions in here for searching and shortcuts for building and stuff like that. It's definitely worth a look through. Okay, so we're finally ready to try to flash the device. You see I got everything hooked up here: video, mouse and keyboard, power, debugging USB port, and the serial port, both connected to the host machine. Now, what's supposed to happen here is when the device powers up, it will detect that there's no SD card in the cage. And so it'll then just start listening on the debugging USB port, waiting for either a query or for a request to download on the bootloader. Now, when it gets the request to download the bootloader, it's supposed to acknowledge to the host, and then the host will initiate the download. Unfortunately, for reasons that I don't understand, either one of two things can go wrong. Either the device can miss the request, in which case the device is still waiting and the host eventually times out, so you can try sending it again, or the device gets the request, sends the acknowledgement, but the host misses the acknowledgement. Now when that happens, you have to repower the device or hit the reset button or something, because once the device has sent the acknowledgement, it'll never send it again. So you can tell when that has happened when the power light on the device goes off. So if the light goes off and nothing good seems to be happening on the terminal, that means you have no choice but to start over by repowering up the device. So I'm going to start by starting up the Minicom port, and then I'm going to go to the README file. I'm going to show you that. I'm going to copy this command. And then I'm going to power up the device. You can see the power light goes on, so he's waiting. Okay, now what has happened here is first of all, you can see the device responded with the query request, so we can see all the information, the type of board and all that kind of stuff. Now after that, the host did send the request. The light is off, so it did send the acknowledgement, but the host is still waiting. It won't time out. This guy will never start over again. So the only thing we can do is power cycle him. And then eventually the host will time out, so we get to try again. So again, we power up that. Try it again. And this time the opposite thing happened. You can see the light is still on. The host timed out, so that means the device did not get the request at all. So now we can just resend the request. And it still isn't getting it. Now, this is very frustrating. You just kind of have to keep doing this over and over and over until eventually it'll work. So the device is just not getting the request. So sometimes just start over. Okay, so now the second thing happened. The light went off. The host did not get the acknowledgement, so that didn't work. And then we wait for the host to time out. Try it again. Sometimes, if you get really frustrated, you can, on the host side, start up the host request, and then turn on the device and you just kind of jazz things up until it eventually works. Now, since the acknowledgement was sent, we got to reset the board. Okay, now that worked. So we can see the device is now flashing. That means it has entered fast boot mode. And we can see on the Minicom terminal, it is saying that fast boot is entered. So we got past the hardest part. So now what we're going to do is we're going to take the SD card, plug it in. Okay, this card is going to get wiped out, so there better not be anything good on it. So now we got the card in, we're going to proceed to the next step from the README file. Next step again. And then the last one. Okay. So now we look back in the README file, and this is the part where I was talking about where it's saying now you go ahead and build the rest of it, but we've already done that, so we don't need to deal with it. Now, it says to hold the GPIO 121 button down, which is this one, and hit the reset button. Now, we don't need to do that because we're already in fast boot. But I'll just show you how that works. So now we have the card set up, so it's not going to be a problem. Okay, so once you have the card with the bootloader installed and you want to go into fast boot, it's very simple. Let me just show you real quick. If we restart the device, you'll notice that there are two buttons on the board. This is the general reset button, and this is the GPIO button. So to get it to go into fast boot, you simply hold the GPIO button down, do the reset, keep the GPIO button held down, let go of the reset, and the device will come up in fast boot. So let me just go through that procedure really quick. So I hold down the GPIO button. Now I do the reset, let go of the reset, and the device comes up in fast boot. From now on with this card, you can do that procedure and you don't have to go through the horrible trying to set up the bootloader.